folks, welcome to another set of Chemistry 1 video notes. Today we'll be covering Unit 5, Lesson 2, Physical versus Chemical Changes. The standards that we're going to cover are here to my left. We have C.1.4, which asks you to be able to describe physical and chemical changes at the particle level. C.1.3, which asks you to be able to recognize observable macroscopic indicators of chemical changes. And C.2.5, which asks you to compare and contrast nuclear reactions with chemical reactions. So way back in 8th grade, you learned definitions for physical and chemical changes. Today we're going to learn very similar definitions, but slightly different. So when we think about this at the particle level, super zoomed in a physical change, the particles of the substances are not broken apart in any way. They could change speed or distances away from each other, etc., but the particles, the molecules themselves, are not split into separate atoms. The result of this is that we have no new chemicals being formed. Now, chemical changes are a little different. In a chemical change, the particles, or molecules, within a substance is broken apart into its separate atoms. Those atoms are rearranged, and they form new bonds, which forms new molecules. The result of a chemical change is that we form new chemicals. So let's take water here, for example. In a physical change of water, say going from solid to liquid, you'll notice that we still have H2O molecules throughout, before, during, and after the change. So before the change, we have these neatly arranged water molecules that are pretty close together, and they form a solid. They don't move around a whole lot. During the change, they start to rearrange themselves a little bit, and then after the change, you notice you have a liquid. They're much more free-flowing, and they can move a little bit faster. The important thing to note is throughout this whole physical change, we always had water molecules, no matter which way they were arranged. During a chemical change, though, we might start with water molecules here, but they break their bonds. The hydrogens and oxygens break away from each other, no longer forming molecules, but they're just separate atoms. Those atoms then rearrange themselves and form new bonds. So we're starting here with 6 water molecules. We break up into 6 different atoms of oxygen and 12 different atoms of hydrogen, and they reform new bonds, creating 3 molecules of O2 and 6 molecules of H2. So in the physical change, we started with water molecules, we ended with water molecules. In the chemical change, we started with water molecules, but we ended with hydrogen and oxygen molecules. So a new substance was formed. Now it'd be great if we could see those particles all the time when we're looking for a chemical or physical change, but unfortunately we can't. The only way to know for sure, without having some crazy insane microscope that shows us the particles, is to test before and after the change occurs to see if you have the same substances. If the substances change, then you've had a chemical reaction. Those tests can often take up a lot of time, or it's just extra steps you have to take. Generally, you can take a good guess. So macroscopically, if you're taking 2 chemicals and mixing them together, you're looking at them without any microscopes or anything, and you see that the color changes unexpectedly, or the temperature changes unexpectedly, or maybe it catches on fire, or there's bubbles that are produced, or a new odor is produced, or you see some solid formed at the bottom of your liquids. So it's called a precipitate. If you see any one of those 5 indicators, it's likely a chemical change. You can't know for certain, but it's very likely that a chemical change happened if one or more of these indicators show up. Now you might be wondering, how does this relate to the nuclear changes we've been learning? Well, that's a great question. Chemical changes and nuclear changes are very different, but they do have some similarities. Here on this slide, the things in red are differences, and the things in green are similarities. So in a chemical change, the way the atoms are arranged into molecules is changed, but in a nuclear change, the subatomic particles that make up the nucleus of the atoms is changed. Because of that, in a chemical change, we get different chemicals that are created. But in a nuclear change, we get different elements or different types of elements, different isotopes are created. In a chemical change, you can affect the speed of a reaction by changing the temperature, the pressure, adding a catalyst, all sorts of outside factors could affect the speed that reaction takes place. In a nuclear change, the reaction is spontaneous. It happens at random, and there's nothing we can do to change the speed of that reaction with outside influences. In chemical changes, we can have endo or exothermic changes. In other words, overall, it could take in energy or it could release energy. But a nuclear change, all of our nuclear changes are releasing energy. They're all exothermic. In a chemical change, the atoms become more stable by changing valence electrons. In a nuclear change, the atoms become more stable by changing the particles in the nucleus. So in both cases, the atoms are becoming more stable. They just go about it in a different way. And last but not least, the one big similarity between chemical and nuclear changes is that no particles are created or destroyed in either of these situations. Well, that was very short and sweet, but that's it for today, folks. I hope you've been able to figure out what you need to for these three standards. If you have any questions, as always, feel free to ask.